The Palo Alto Networks firewall, and this is layer 3 participation. Some of the concepts about what we're going to get into and what kinds of things that we can do at layer 3 with our cool firewalls. Alright, so once we get into the wonderful world of layer 3, you got to keep in mind that my Palo Alto Networks firewall can actually provide a lot of services. So, I can do stuff with routing, I can do stuff with network address translation. Well, of course, DHCP also kind of comes with the territory. But everything revolves around that concept of virtual routers. So all layer 3 interfaces by default are in a virtual router, a single one called, well, default. So everything out of the box is pretty much by itself whenever you stick it into L3 mode. Anything in a virtual router shares the same routing table. So if you have multiple virtual routers, you have multiple routing tables, each of them being separate from each other, and you have to then assign your interfaces to which VR you have. Everything we're going to do in here, by the way, is going to be based on specifically what box this is and what you're actually licensed for. So licensing and capabilities, two certainly different things in there. Now, in general, whenever I want to run layer 3, one of the big things to be concerned about is management. So what am I going to do about it? What am I going to allow in there? Am I going to, show up? Do the users get to see me? Do they get to talk to me? All of those kind of fun things that go with it. So look at it, because by default your management traffic should, change my color here, come into my management interface, which is, wherever it's going to be, but it's a separate interface on there, specifically called management. So it's the one that we've dealt with so far in our initial setup and everything along those lines. That's where management stuff comes. If you want it to come in to any other interface, well, you have to allow it. You have to set up a management profile. So very simple things in there. It's really not too difficult to do. Independently, you'll set up your interface management profiles, reflect what type of traffic that you want to allow into each of those interfaces. And by into, I don't mean, like I've got to specify that FTP is going to come through or that any special apps or anything like that. Transit traffic and control traffic are two completely different ideas. So a management profile is specifically for control traffic information that is destined for the Palo Alto box itself. So if you want this guy to respond to something, like a ping as an example, if you want your users to ping the firewall and get a response, that would have to be set up in the management profile in there. Okay, so very simple thing, ICMP, or I guess we'll call it ping in particular, is going to be my primary one that I would suggest doing. That's just one of those things. I personally do it to every interface that I have configured just to make it easier so I can do some tests, so I can troubleshoot with my users and things like that. I understand security rules for not wanting your firewall to be visible. Maybe don't make it visible from the outside world. Whatever works for you, but at least in some situations, just for purposes of testing, I find it a lot easier to do. Think about talking to your users. You can do it without having pings. That's not necessarily the end of the world, but let's take it from a user perspective. If I have a user that's out here who's experiencing problems and I want to say, hey, can you ping your gateway? Presumably that gateway is the firewall. And the answer is no. Well, okay, so I sit there and remember, oh yeah, well, I don't have that management profile set up, so okay, I know your ping failed, but can you now type ARP space -A and hit enter? And now you might have a lot of stuff on there, so let's kind of scroll through it. Oh yeah, there's more than one page. Okay, so let me do an ARP space -A space pipe. That's a vertical bar thing, and the word more. And you're kind of sitting there going, what? And trying to explain that to users and get that where you get the information you want out of it is not really an easy thing. So when we look at this, we try to make, not only our users' life a little bit easier, but particularly our life if we have to support them. I would just recommend, at least on my internal interfaces, going ahead and allowing the pings on there. But we've got other stuff. You have, Telnet, Telnet, or SSH that you could put up there. I can do HTTP, HTTPS, and again, this is for stuff destined for the firewall, which means management. Okay, so this is the GUI stuff on here. Not that my web server is going through it or anything else. Transit traffic, not part of this at all. Okay, there's also SNMP, and there's a few other things on there as well. But bottom line, if you want your firewall to respond on anything other than the management interface right here, you need to set up a management profile and tie it to the interface. The other, I guess, piece of information that's pretty important when looking at management anyway is a service route. Okay, so service routes are set up in order to, well, pretty much exactly what they look like. It's if you want to make certain services come from something other than my management interface right here. So we could do SNMP traps as an example. In device setup services, so change my color here. Okay. Inside here at the bottom there's a service route configuration, and per service now you can actually change the source address. So default, of course, is going to be the management interface, but I could have my SNMP traps, as an example, originate from this interface right here because my network management server is in the data center. So I mean, some things may just make more sense by virtue of what is going to be listed where. Okay, so kind of look at that, check it out, go through the list. I do have separate settings, by the way, for both IPv4 and IPv6, at least in PAN-OS 6.0 and later anyway. There's varieties. We got to 5.0, some things were v6 enabled, some weren't. In 6.0 there's a whole lot more that is. So kind of moving forward, think about that in case you're doing dual stack or worrying about that stuff. But layer 3, doesn't matter whether I'm doing v4 or v6, layer 3 capabilities, I have all sorts of things to be paying attention to. Now, back to my concept of virtual routers in here. Okay, so virtual routers, like I say, is a way of carving the box up to pretend to be or to function like multiple boxes. Okay, so multiple separate systems at that point. And really, whenever I want to go set stuff up in here, it's all under the network. So network tab, and then virtual routers. So really pretty straightforward as far as where it is and what I'm configuring. Now, like we said, by default, there's one that exists already, and all interfaces actually belong to it. You can set up as many as your license or hardware happen to allow in there. Now, once I'm inside of VR, think about routing tables. Okay? Remember, when a packet comes in, a lookup is done first in order to determine the policy. So let me clear this part off here real quick so we can refresh our view on what that flow logic happens to be. Okay, so let's look right here for our initial packet processing, source zone address where it comes up at, but the lookup right here is the part that I need to be thinking about. Okay, and that's what's going to determine my destination zone. It's going to determine the NAT policies and stuff like that to see what's going to be going on with it. But during this lookup phase right here, that's going to be contingent on what my virtual router allows me to see. Okay, so what is in my routing table for that particular virtual router? Excuse me. All based on my incoming source zone and address. So that's kind of one cool thing to be thinking about when we start looking at that. I'll go ahead and clear this off now. Now, as I get into my virtual routers, I can route between my virtual routers. I would need a static route to do that, so that can be configured to do in there. But otherwise, everything is going to be separate in terms of my routing tables, in terms of my policies, in terms of the lookups that we're going to be doing for that. So very simple stuff. So under network, under virtual routers, that's where I'll decide what belongs where at that point. Right, so NAT is really kind of my next section, checked off virtual routers. So NAT is really the next thing that I want to look at, and that's actually a large part of what firewalls tend to do. We can do both source-based and destination-based translations based. Okay. All right, so all these things in there, and everything that we do in here is going to be based on the policies that I have set up. So when configuring your NAT, it's really kind of important to note that a security policy must also be configured to allow that NATed traffic. Again, when we looked at the packet flow in there, the order of operations, the policy will be matched. Okay, so let's see, policy on PostNat. Okay. So look at the PostNat address as far as where we're going to be going to, and as far as incoming, my source anyway, is going to be prenet. So I will need to think about, depending on which one I happen to be doing here, what I'm going to be setting my policy on. I guess, bottom line, and I'll tell this to pretty much every class that I happen to teach, no matter what one it is. If you can think like the device, okay, so whether a router, a switch, a firewall, no matter what it is, put yourself in position of, I'm going to sit right here on this box. I'm going to be the firewall. And if you can start to think like the firewall does and say, okay, here comes something in this interface, what does it look like? What do I see? What do I do next? That's going to help you a whole lot when it comes to this configuration and this thinking about stuff like policies and translations and all the other gobbledygook that comes with it. Because believe me, there's a lot of stuff. But concentrate on putting yourself right here, right in that middle right there, and say, here's where I'm sitting, here's what I want to see, here's what I want to look at, and here's what I want to think about for where we're going to be. Now, with SourceNat stuff, so do my colors here. So in SourceNat, I can do static. And at this point, static is a one-to-one layer 3 translation. So very simple stuff. I can do dynamic IP, if I can spell today, dynamic IP, which is also one-to-one, but it is going to be a, I would call it FIFO. Okay, so first in, first out, or otherwise first come, first serve, one-to-one layer 3 translation. So it's just based on the next available address in the pool, no matter what host or user happens to come in next. So there's no specific sequential order for it at all. And then I also have dynamic PAT, which is port address translation. And this is, honestly, well, for right now, we'll just call it an X to 1. It could be an X to Y because I could have more than one IP here, but generally speaking, everybody gets translated to one address. With Dynamic PAT, I can actually use the interface address of the firewall as where it gets translated to. So I do have some options in there. But bottom line in here is that while in these two, my port or my L4 information, layer 4 information stays the same, in Dynamic PAT, my layer 4, my port changes. So my source port anyway, this is all source-based stuff. So what port number I'm coming from is going to be different. And I'll just do this, again, in a sequential order, starting at port 1024, going up to port 65535, and then rolling over. In case we're wondering about the 1024 part, that's the barrier for what's known as the ephemeral ports, or variable ones, user-defined, I guess whatever term you want to use, but not the well-known ones. Anything below 1024 for a port number is listed as well-known ports, and so generally we don't touch those. But that's just kind of the baseline idea for things. So that's my ideas for source-based NAT. Now, destination-based NAT, on the other hand, again, I have some options, but really I do it from a static standpoint. So static in this case, again, is a one-to-one translation. So it's going to be, whatever I configure, this one is always changed to this one, so on and so forth. The other part I can do is kind of port-based, but here we call it port forwarding. And in port forwarding, obviously, like it says, there could be multiple, so we'll say one to many. there could be multiple different port numbers. So I've got 5 different web servers here. Obviously, web traffic is on port 80. Well, maybe I tell all my people in the internet or wherever they are, I'm going to have my main one is port 80, but I'm also going to have an 81, 82, 83, and 84. Now, in my servers, each of these really is port 80. So I have to translate from 84 over here to this IP at 80, from 83 to this IP at port 80, 82 to this one, and so on and so forth. So you kind of get the idea what port forwarding is, but this gives me the ability out of one single IP address over here to get services in many different locations on the inside, or many different things on the inside. And I could even use well-known ports, like in email ports or FTP ports. So, email may go over here to this guy, FTP may go to that guy, web servers maybe over here if I have different ones set up. So I've got lots of options that I can do by port forwarding, still using a single IP address on the outside. This is great, especially in today's world where the IPv4 addresses are pretty well exhausted. So calling up your, it's not like the old days where you call up your provider and say, hey, I need 2 addresses, and they give you 200. It's really not like that anymore. Nowadays it's I need 200 addresses and you might get 2 if you're lucky. Okay, so that's kind of the idea where we're at with this. But everything with NAT, like I said, has to do, when we look at that flow logic, remember up at that top corner, we had NAT policy evaluated up there. That's part of the initial processing stage. That's where the post-NAT zone is looked at, and policy for that matter, kind of make sure everything is cool in here. Everything for a NAT rule, however, is placed in the pre-NAT zone. So any translations and stuff that I'm going to do. So we kind of watch for where we're at and where we're going and how that's going to be. So NAT rules in the pre-NAT zone, security policy, on the other hand, residing in the post-NAT zone. Like I said, place your butt right here in the middle and think about how things are going to look and where I'm going to be thinking about. Because knowing that flow is the most important part of understanding NAT and really understanding the Palo Alto firewall, especially in terms of either the ACE or the CNSE exams that you're going to take. Okay, those are both going to be big portions of it. Definitely understand this on here. Now, Palo Alto, by the way, certainly does IPv4 based NAT. We also do, so I'll put IPv4 or, NAT 64. Okay. Inside IPv6, by the way, there is no network address translation. It's against the rules. So you can't do v6 to v6 network address translation. That would pretty much be insane anyway, so don't do that. But I can translate between v4 and v6, and that's called NAT 64. Your Palo Alto Networks firewall, at least in version 6.0 and later, does support NAT.64 or NAT 64. So kind of keep all that in mind as you go for it. So that's pretty much going to be NAT as far as I'm concerned in here. Really, my next idea, clear this a little bit here, is DHCP services. Now, DHCP services are actually, well, pretty simple. Okay, so we did this already, did that already. Now we're going to look at this. And honestly, for DHCP, I can do 2 things. Okay, I mean, that's really as it is. So I can either be a server, so I can configure my Palo Alto box to send IP addresses to whatever hosts that I have on there, or I can be a relay, which means that I will forward a DHCP request from here over to, I guess probably DMZ, but wherever my DHCP servers happen to be, or they happen to reside in the network. If I'm a server, by the way, the server itself can be enabled, disabled, or auto. In auto mode, it will hand out DHCP addresses unless it hears some other DHCP server respond. So that's kind of a good way to set this guy up as being a backup for your DHCP, because if it hears a DHCP, it's like, no, that's not me, I'm not going to do that, okay? And that way your users will still get it from whatever your normal DHCP server is. But in the event of that failure or something not responding, you don't want your users sitting out there going, I got nothing, I got no address, I can't get anywhere. So in that case, putting it to auto and configuring it, of course, will allow your Palo Alto to hand out addresses as necessary. So kind of nice things to do. But that kind of gives the example or the different ideas as to where we can be set up. Relay, by the way, I can forward things on to, I guess it'd be this way, up to 4 servers. So you can copy them to multiple locations then. DHCP, by the way, is a first response is who wins kind of thing. So first come, first serve in terms of getting responses. So I will copy them to all 4, and whoever responds to the user, that's kind of who wins. So that's my gist with DHCP and the Palo Alto. Now, last but not least, we get into the wonderful world of routing. So routing in here, of course, we can do static routes. That's kind of the, I guess, baseline for everything to get into and what we can do in there. But I can also do dynamic routing. So dynamic routing in the Palo Alto world, I can do RIP v2, I can do OSPF, and I can do BGP. So really all the cool things that we have going on. From a design standpoint, okay, this also gets very interesting. I suppose I'll put on here we can do route-based VPNs too. Now, like I said, from a design standpoint, this gets very interesting. It's good that we can participate in dynamic routing protocols, but the general question is, should we? Are you going to be a firewall or are you going to be a router? That's really what a lot of things boil down to. And part of that kind of comes into play with design considerations in here. It's funny, I was actually participating in a Packet Pushers podcast the other day, and that was exactly one of the things that we were discussing, is whether to do any routing on our firewall or not. And the general gist that we kind of came up with is it's okay to do BGP, but really not advisable for doing anything else. And a lot of it just comes down to simple processing. Your firewall is a firewall. It is designed to, decode a whole lot of packets, to do a lot of policy stuff. Basically, it's doing a lot of work. And now you want me to do what? Yeah, so kind of think about those things. So RIP version 2, okay, so it's nicer than version 1. However, you still send out your entire routing table every 30 seconds. And you have to calculate based on that. All right, kind of a pain in the butt. In OSPF, I do only send things out when there's changes because I'm in link state, well, other than my refresh every 30 minutes, but beyond that. But anytime there's a change, I do an SPF calculation. So I'm recalculating my entire database or my entire topology based on a change in there. Some routers do what they call incremental, but the firewall does not. So, yes, there's advances in the protocol, but not so much on the firewall. So we have basic OSPF functionality on there, which could lead to a lot of processing, depending on how many routes you have and how many changes and things like that. And the question is, do you want that to occur? Generally, the answer is no. BGP, on the other hand, is not... so any of my IGPs are concerned with reachability and fast reachability. BGP, on the other hand, as just general routing, is concerned about stability. So it's not as talkative. It doesn't tell me as much about what's going on. There are delays built into it intentionally. You're not designed to run your entire network on BGP, but BGP becomes a lot safer to run on a firewall because there are fewer changes. There are fewer flaps, fewer problems going on with that. So if you're going to run layer 3, just from a general design standpoint, my consideration would be use BGP or just don't use anything at all. Static routes may be fine for you also. If I have another router up here and I only have one way to go, well, there's my static route. One way makes things simple. I don't care how many destinations he has. If that's my only path out, that would be a static route. So, but anyway, keep things simple, keep things as easy as you can. You do have options. So like I said, the route-based VPNs are supported. Multicast multicast routing in particular is also supported on my Palo Alto networks. So that may be of interest to you. I have IGMP support. So that is my Internet Group Membership Protocol. It's the user-based stuff. So I would definitely have that configured wherever I have users or servers that may join particular groups. I have PIM, both dense mode and sparse mode. Sparse mode, by the way, is definitely the recommended one from a design point of view. I do also have source-specific multicast. That's not particularly a mode right here. So PIM v2 is what we're capable of. IGMP, I can do v1, v2, which is default, or v3, which is my source-specific multicasting. So I got lots of different options on there as far as what we can do if you have multicast. Configuration-wise, you got to have a need to do multicast to do it. Config portions probably not going to be a tested thing, so I don't know if I'd spend a whole lot of time with it, but just generally what it does support or does not support, I would be aware of this from an examination standpoint. So that would be another part. In terms of my layer 3 routing, one last thing to kind of take a look at that I do have as a possibility is what we call PBF. Other vendors call it PBR, policy-based routing. Palo Alto calls it policy-based forwarding. So basically, it's my policy that says, based on this type of traffic, go here. We apply it to our zone, say where I'm going. There must be, so must have, a 6-point match. Okay, so 6-point match in here is going to be source address, source zone, and user, plus my destination address, my application, and my service or port number. So I have to have a match in policy for all 6 of those things in order to effect a change and say, hey, based on exactly this stuff, go that way. And that would be another option of my forwarding. But that pretty much concludes the concepts as far as what we have for layer 3 participation from my Palo Alto firewall. Alright, so we've done some cool things in here as far as my layer 3 goes. We have definitely talked about our wonderful world of virtual routers, which is what everything revolves around in the routing tables therein. So all the cool things with that. We've talked about our different methods of NAT, so both source and destination based, and the idea is that we need to really pay attention to the flow. Flow probably being the most important part in there. That flow chart, and again, as we talked about early on, you're going to have lots of concepts to be thinking about in terms of that logical flow in there from your examination standpoint and just real life when I'm thinking about my policies. So flow is very important for it. We talked about our wonderful world of DHCP from both the server or the relay point of view, and then of course our routing, both static and dynamic. So what did we have for my protocols again? Let's say I had static, I had RIP v2, had OSPF, BGP. Oh yeah, and that policy-based thing, that PBF. But those are all the things that would affect my forwarding in terms of, I guess, the wonderful world of routing. If I'm doing v6, by the way, I do have OSPF version 3, where I have static. So those would be my differences in there. All 4 of these right now are available for IPv4. So that is Layer 3 concepts. I hope this has been informative for you, and I'd like to thank you for viewing.